That is for maximum. And if double derivative is greater than 0, then it is point of minimum. So this is the theoretical part in short, what we have to do. Now, if you see the application, first write this. So I hope you have written it. So the question which we have here is right now. Find about maxima and minima of fx is equal to 2x cubed minus 15x square plus 36x plus 1. So first you have to find the critical point. So you differentiate it and you will get 6x square. And then it is minus 30x plus 36. That is the derivative. Okay, is it fine?
Yes.
Okay. Now it cannot be undefined because it is a polynomial. So it can be 0 only. So we equate it to 0 and we take 6 common and it will become
Minus
x
5x
square
plus 6.
Yeah, 6 is outside. X square minus 5x plus 6 equal to 0. Now we will do the middle term splitting. So it will be x square minus 3x minus 2x plus 6 equal to 0. So it will be 6 and x into x minus 3 minus 2 into x minus 3 is equal to 0. So from here what happens? 6 into, you take x minus 3 common and x minus 2 equal to 0. So you write it till here. So from here, what you get? You get x is either 3 or it is 2. X is either 3 or 2. Now, these are the critical points. After getting the critical points, you have to decide that which one of them is a maxima and which one of them is a minimum. So what you will do, you will again differentiate this function, this f dash x, and you'll find f double dash x. So when you will differentiate it, you will get 12x minus 30. Now just find the value at 3. This 3 is there. So you will get into 12 into 3 minus 30, which is 6, which is positive. And then again, when you differentiate it, and you put the value 2, another value is 2. So f double dash 2 is 12 into 2 minus 30, which is minus 6, which is less than 0. So basically there is a minima at x is equal to 3. Because double derivative is positive, and maxima at x is equal to 2 because double derivative is negative. So this is how we find it out. Okay, Shavaz. So we have the next question here. Let y is equal to, you can write fx as y also, x plus 4 by x square, and x is not equal to 0 obviously because denominator cannot be 0. Find the maxima, point of maxima and minima. And also find value of the function at these points. Hmm. So what you have to do, you have to differentiate this y and equate it to 0. And also you can check for undefined, but keep in mind that x should not be 0. And then you have to find the maxima or minima and the value of this function at these points. So just try this. How are you proceeding it? What is the derivative of this function? What is dy by dx?
It is 1 minus 8 by x cube.
Yeah, correct. Now, what you have to do is you have to equate it to 0 for critical point. In undefined, you cannot take, because if you want to take undefined, then you have to take x as 0. But already in the question, x is not equal to 0 because the function is not defined at x0. So you can't take infinity or undefined. Yeah. So from here, when you take 1 minus 8 by x cube equal to 0, what is the value of x that you are getting? Shavaz is saying x is equal to 2. So that is fine. 1 is equal to 8 by x cube, which implies that x cube is equal to 8, which means x is equal to cube root of 8, which is actually 2. So x is coming out to be 2. Now we have to further confirm that this is a point of
Point
maximum.
of minima.
Sorry. So for that, what you will do, you
It is a point of minima.
point of minima. So we will see, we will differentiate it again. So it will become 0 and it will be plus 24 by x to the power 4. So you will see it as 24 by x to the power 4. Now when you put x is equal to 2 here, so double derivative of this at x is equal to 2 is equal to 24 by 2 to the power 4, 16, which is 3 by 2, which is greater than 0, right? So we say that this is a point of minima because the double derivative is positive. And also you have to find that after getting x is equal to 2 as the point of minima, what is the value of y at this point? So y, what it was? X plus 4 by x square. So when you will take x is equal to 2, this will become what will be the value? Three. Okay. So this will become 2 plus 4 by 4, which is 2 plus 1, that is 3 will be your answer, right? So the minimum value is 3. So one answer is this. This is the point of minima and this is the minimum value.
So how is it my x 3/2 is greater than 0?
Yeah, 3/2 is greater than 0, no? So this will be the point of minima, 2 will be the point of minima. Three by two is a positive number. So this x is equal to 2 is a point of minima, right? This 2 is what we obtained, where dy by dx is 0. Then
Yes.
okay. So the next question is find the local maxima and minima of the function fx is equal to 3x to the power 4 plus 4x cube minus 12x square plus 12. इसको पहले you have to first differentiate it. So differentiate it first.
So I'm getting 12x cube plus 12x square minus 24x.
Okay. So when we will differentiate it, we are getting 12x cubed plus 12x square minus 24x, correct? Now you have to equate it to 0 and see what are the values of x which you are getting. What are the values of x which you are getting after equating it to 0?
X is equal to 2 and minus 1.
Okay. 0 will also come, na? This will become 12x common, x square plus x minus 2. Then it will become 12x, and here you will do the middle term splitting. You will get x plus 2 into x minus 1, right? Is equal to 0. So there are three values. 12 is a constant, and x could be 0, x could be minus 2, x could be 1. So these three values are coming, right? Now you have to further tell that which point is the point of minima or the point of maxima. So you will again differentiate this function and you'll get 36 x square plus
X is equal to 2 is the point of minimum, and x is equal to minus 1 is the point of maximum.
Let us take 12 common, right? So this will be 3x square plus 2x minus 2. Okay. It will be easier to calculate now. Now, when you put x equal to 0, what is the sign you are getting? When you put x equal to minus 2, what is the sign you are getting? When you put x equal to 1, what is the sign you are getting? F double dash 0 क्या आ रहा है अगर put करेंगे तो? What is the value of F double dash 0? Minus 24, isn't it? F double dash minus 2 अगर put करेंगे तो क्या आएगा? 3 into 4 minus 2 into 2 minus 2. तो ये हो जाएगा 12 minus 6, 6 into 12, 72 आ जाएगा. And then we have F double dash 1, so 12 into 3 plus 2 minus 2. So this will become 36, right? So सबसे पहले you have F double dash 0 minus 24, which is a negative value. F double dash minus 2 is a positive value. And F double dash 1 is a positive value. So you will say that point of minima. There are 2 points of minima. Points of minima. So points of minima are -2 and 1. Okay, so they are positive. And point of maxima, where double derivative is negative, so x equal to 0. Is it clear? Let us come to the next question.
So 1 minute. Yes, sir.
Okay. So the next question is application type question. Prove that the radius of the right circular cylinder of the greatest curved surface area which can be inscribed in a given cone is half that of the cone. So let us understand this question and make a figure. It says to prove that the radius of the right circular cylinder of the greatest curved surface area which can be inscribed in a given cone. So let us suppose this is the cone. Okay. And it is a given cone. So what do you mean by a given cone? So given cone means that the radius of this cone, suppose, is capital R, which is given to us, and height of this cone, capital H, it is also given to us. That is the radius of the base, circular base, and height of the cone is given to us. And you have to inscribe a right circular cylinder. So if you inscribe a right circular cylinder in this, which may be of something like this. So this right circular cylinder is of the greatest curved surface area. You have to prove that is what is the curved surface area of a cylinder. If you suppose this cylinder has a height small h and has the radius small r. So what is the curved surface area of the cylinder? Do you remember the formula of curved surface area of the cylinder? It is 2 pi RH, isn't it? Okay. Now this curved surface area has the greatest value. Now that depends upon H and R both, because if you suppose take a curved surface area, which is, take a cylinder which is like this, then its curved surface area will be something else, and radius and height will also change. So you can take any type of cylinder inside this cone, which has different area, radius and different height. So here, if you want to find the greatest curved surface area, let us denote it by capital A. So it depends on two things, R and H. But you can't differentiate with respect to R and H both. You have to bring it in terms of one variable. So how can you bring it in terms of one variable? First write this, then I will tell you.
Sir, what is the meaning of right circular cylinder?
What is the
Meaning of right circular cylinder?
it is simply a cylinder. The normal cylinder which we study is called right circular cylinder. You have studied in class 9, 10th, 8th about geometry and all, measurement and all. Volume and area of solid curves like this. There are some chapters in 9th, 10th. So there we study cone, there we study cylinder, sphere, cubes, cuboid. Have you written this?
Yes, sir.
Okay. Now, if you see this figure, what is happening here? Let us take this as a vertical line passing from the vertex to the base, this line. I'm drawing it in another figure. So this height is capital H from here to here, which is the height of the cone. And this is a cylinder, right portion of the cylinder, and its height is a small h. This is the radius of the cylinder, which is a small r, and this is the radius of the cone, which is capital R. So this type of figure we are getting. Now, if you see this figure, you can say that there are two triangles. One is this bigger triangle, and another one is this triangle, which is a smaller triangle, this one. And these two triangles are similar because A, B, C, D, E. So triangle ABC is similar to triangle ADE, right? ABC triangle is similar to triangle ADE. Similarly, by A is similar. So we can say the sides are proportional. So AB is having H height and the radius is capital R. Similarly, for a smaller triangle ADE, the height is H minus H because this remaining height will be h minus h, and the base is small r. So we can write it like this. Now, after writing it like this, we can take h r by capital R is equal to h minus h. So h will be equal to h minus hr by capital R. So this is what we will get. Now, from here we can say that h is equal to h1 minus r by r. So this is a relationship which we are getting between small h and small r. Capital H and capital R given. Small h and small r are varying. Okay. So write till here first. Yes, Shabazz, I'm saying that there are two triangles. One triangle is triangle ABC, right? So we take triangle ABC here and triangle AD. Both of this triangle, as you see in the figure, these are similar triangles because this angle is angle A, which is common in both the triangles, and this angle is 90°, which is here also 90°. So this is also 90-90. So A similarity, we can say that these two triangles are similar. You have studied similarity in class 10. Now, if the two triangles are similar, the sides are proportional. So if we take triangle ABC, so it's AB length by BC length. This is actually AB by BC, which is H by R. And AD by D. So this is AD by D, which is H minus H, and D is R. Now you cross multiply. So HR by R is H minus H. So H is equal to H minus HR by R. So small h is capital H, 1 minus small r by R. That is what you are getting here. Is it okay? Okay.
Can you explain this again?
Sorry.
Can you explain this again?
Yeah. So where you have problem, Sharif? Which step?
Sir, the third last step.
Sorry.
The third last step.
Third last. This step.
About that.
So here we have multiplied this to h. So it is HR by R is equal to H minus H.
So how did we get this?
Sorry.
How did we get this?
We get by similar triangles. Like we have this in similar triangles, sides are proportional. If you take two similar triangles, so in similar triangles, we have studied in class 10, corresponding sides are proportional. So the triangle which we are taking are actually similar triangles. Triangle ABC and AD. Can you see this? These two triangles, ADE and ABC.
Yes, sir.
So these two are similar triangles. So you can take the sides AB by BC is equal to AD by DE. So AB is H, capital H, and BC is capital R. AD is capital H minus a small h, and DE is a small r. Okay.
Okay, sir.
Done. Written down.
Yes, sir.
Okay, so we have this A as 2 pi RH, right? So we can now write this A as 2 pi R, and H we will replace from here as capital H1 minus R by R, like this. So we write it like this. This can be also written as 2 pi HR minus 2 pi HR square by R. When you will open the bracket, this is what you will get. Now dA by dr is equal to 0. The derivative of the curved surface area with respect to the radius of the cylinder is 0 if you want that to be maximum, for A to be maximum. So the variable here is like we take yx now. So here A is treated as y and R is treated as x. Now you differentiate it. So when you differentiate this one first, you will get 2 pi h, because dr by dr will be 1. And second one is 2 pi h by capital R, and R square will become 2R and equate it to 0. Is it okay?
Yes, sir.
Now you take 2 pi h common. So you will get 1 minus 2R by R is equal to 0. Now 2 pi h are all constant. They will become 0. So 1 minus 2R by R is equal to 0. So you will further say that 1 is equal to 2R by R, or you can say R is equal to 2R, or you can say R is equal to capital R by 2. So if you see the question was asking radius is half of that of the cone. So you can clearly see here that the radius of the cylinder is half of the radius of the cone. So you can say hence proved. Written.
1 minute.